Hi everybody, it's Mr. Bennett here. Now I'm going to do an introduction to polynomials video today. And so the one I've got here in front of you is in fact a cubic polynomial. And the thing I want you to notice here with this one, it's really just an extension of the quadratics that we've been doing in class. So if we're looking at the x-intercepts, we've got an x-intercept here at -1. We're going to intercept here at 3, and we've got an intercept here at 5. So if we did all of the, what they call the linear factors of that, that would become x plus 1 over here. This one over here would be x take 3, and that one there would be x take 5. Alright, so then that's what we've got there. So the equation of my polynomial would be just really the multiplication of all those terms there. Now, if you expand it out, what would happen is if you times all the x terms together, you're going to get an x to the power 3 term. You're going to get some sort of x squared term. You're going to get some sort of x term. And you're going to get some sort of number term. Now, I'm not going to times it out, but you could do that, and that will tell you the equation of the polynomial. It will generally be given in that form. All right, so now I want to start by looking at just some general stuff. So a polynomial can be anything. So our first polynomial we've got is a linear polynomial. All right, and that's in the general equation y equals ax plus b, or we call it mx plus c. The number of turning points for that is 0. The next one we might be looking at is a quadratic. So we're looking at a quadratic. That would be in the form of y equals ax squared plus bx plus c, and that's got 1 turning point. The next one we're going to be looking at is a cubic. Alright, so that'd be in the form of y equals ax cubed plus bx squared plus cx plus d, and that will have 2 turning points. Then we get into maybe doing a quartic. That's got a power of 4. So it's the leading coefficients, the key thing. That will be ax to the 4 plus bx cubed. Now, even though it's got all these terms, it doesn't actually have to have an x cubed term or x squared term. All right, that's the leading coefficient. That's the thing that's important. That's the first one. So it's that one in this particular case that makes it a quartic. All right, so that's the key thing there. When we start talking about that, so let's go finish off dx plus e. All right, so you get the idea. I don't even know what they call the next one, but you know the next one would have a y equals ax to the 5, and then you'd go y equals ax to the 6. Now most of the ones that we're going to do will probably finish at that line there. Now if we were just doing a sketch of these things, we know a linear equation something like that. We know a quadratic goes something like that, or the other way around. A cubic could go something like that. It's got 2 turning points. Now I didn't do the number of turning points here for this one here. So it's going to be 3. And guess what? This next one's going to have 4. And this next one's going to have 5. The number of turning points is always 1 less than the leading coefficient, leading power. Alright, so if it's got a power of 3, x to the power 3, then it's going to have 2 turning points. If it's going to have x to the power of 10, it's going to have 9 turning points. Alright, possibly with that. So when we start talking about turning points are things where it goes from, these are where the slope of the tangent is equal to 0. Alright. Now, this is just one little this is one little thing that you need to be aware of. You've seen some of these graphs already. I can get a graph coming down like this. All right, so I've got a graph coming down like that. If that is my graph, that is equivalent there. It's called a horizontal or a stationary. This is called a stationary inflection. And that accounts for 2 turning points. So every time you see one of those, that is equivalent. So this would be an x to the power of 3, and that there is going to be an x to the power of 3. All right, so I'm going to stop the video here, but the introduction to this is to say a polynomial is any function that we could draw in our calculator with an x power of something or a y power of something. Okay, it doesn't have to be x, but we just generally use x because that's our x and y axes. But it's got a power, and it could be a linear equation, it's a polynomial. We just call it a straight line. It could be a quadratic, it's a polynomial, but we call them quadratics because they're special. And it could be the power 3, but we're going to call that a cubic. Right? But they're all polynomial equations. Now, when we start talking about solving problems, okay, as we were seeing in our quadratics, is these turning points, these critical points are really important, okay, because they tell us our local maximum or our local minimum, and they are the most useful points. All right, we'll go on with this particular stuff in the next video.